everybody attending this webinar, where we have a talk given by Hannu Flinck. And the talk is about 6G architecture, which is supposed to be a very hot topic. Title is 6G architecture to connect the worlds. So this is actually one of the first invited talks organized by Mosaic Lab, which I'm directing within the Communications and Networking Department within the School of Electrical Engineering at Aalto University. So before we start the talk, I would like to briefly introduce Hannu Flinck. Hannu Flinck is a senior research project manager in the area of future networking that contains 5G, evolution, and 6G network architecture in the Standardization Research Lab of Nokia Bell Labs here in Espoo in Finland. He's an active contributor to different standards bodies, including 3GPP and IETF. He has been involved in more than a decade in university collaborative projects related to computing and networking. He obtained his master's degree and bachelor degree in computer science and communication system from Helsinki University of Technology, which used to be the old name of Aalto University. Hannu, the floor is yours.
Thank you. One correction, it was a licentiate.
Licentiate.
All right. Yes, it's an old degree which doesn't exist anymore. All right.
Yeah. By the way, one of the things which I forgot mentioning to the audience, if you're familiar with Zoom, there is a tool which is called question and answer on the menu on the bottom. Please feel free to write down your questions. We will use those questions to build a dialogue with Hannu about the content of his presentation. So these questions can be put, during the course of the presentation or towards the end. Thank you.
Okay, good. So what I'm going to present is our current view on 6G architecture. And this presentation is based on a recent article that we published in IEEE Access article. And I have presented same material, almost the same material in the IETF side meeting. And I thought that this would be interest of you who are dealing with network architectures, protocols, and communications in general. So let me see how to change the page. So let's see first the timelines and what's happening. So currently, of course, everybody's working on the 5G releases. The first generation of 5G or phase of 5G is ongoing. We are entering to the evolution period, and this 5G is still moving targets. There is a lot to happen there, and it will continue at somewhere to 2026, and then gradually fade away, and more attention will come to 6G. So by this timeline, we are anticipating that 6G standardization would start somewhere after 2025, 2026, which means that we have some 5 years for the basic research, and of course there are these supporting EU flagship projects, and then the subsequent Horizon Europe smart networks and services. And this research for 6G architectures that they start with 6G technology component evaluations and development, and then after a few years move into more of the system level research projects. And then, as I said, we will start 6G standardization, where 3GPP is expected still to be the key player there, and of course there will be other supporting for most likely open source activities will have important role there, and then the protocol developments in IETF and elsewhere will support the 6G development, and the commercialization will happen then somewhere 2030. And here you see the World Radio Congress, where we are expecting to get new spectrum and refarming the existing spectrum for better usage. So with that background, I think it's worth of looking how this 5G evolution, architectural evolution is going to continue before we jump into 6G. So as each of you should know, the 5G, the biggest thing in 5G era was this introduction of cloud native microservice-based architecture. And this cloudification of networks, this is going to continue, at least in the next 2 3GPP releases, with various type of enhancement and optimizations, especially better support for distributed cloud computing in terms of edge computing integration, new capabilities in virtualization, abstraction and sharing physical resources. This is not only referring to slicing, but also the APIs and how these physical resources are exposed to services, and then on-demand automated learning management functions. So one big thing what's now at the 5G evolution phase is the introduction of machine learning and artificial intelligence. So let's look at then the subsystems of 5G architecture and how they are foreseen to evolve. So currently, the current setup is such that we have these radio units and distributed units. They are in the cell sites. They are embedded closed systems, and then in some cases the centralized units, which is in charge of radio resource control and packet data convergence protocols, could be in the central cloud, or typically it's still on the cell side. But what is now coming after that is virtualized run 1.0, and what that brings more is that the centralized unit is in the edge cloud. In virtualized run 2.0, also the distributed units is virtualized, and it will be implemented in edge cloud, but that's only virtualization. Then in the future virtualized run 3.0, even the distributed unit will be decomposed into microservices, and thus it will leverage cloud native capabilities. So it's going to scale according to dynamics of the traffic and the cloud facilities, what's offered. And here, of course, the accelerators and this hardware exposure plays a critical role. In addition to that, there will be some developments in the radio side. There will be a light version of the new radio, NR Lite, and this is meant for higher data rates and better reliability and lower latency, especially for IoT type of devices where the battery lifetime is a critical factor. So battery lifetime should be order of years. So all the extra signaling and complexity is carved out from this NR Lite version. Then moving on to evolution of 5G core network. As you know, 5G core is already service-based, which means that by definition, the network functions, they are exposing services. The network functions are defined through these REST-based APIs that they are offering to each other, of course, a key component there is a service discovery functionality. And the basic set is now set up, and this is what already we are deploying. What is going to evolve and what is going to be worked more is the optimization and new functionality needed to support vertical sectors. For instance, industrial IoT, time-sensitive networks, non-public networks, traffic steering. These kind of additional features will be introduced for the core network. Also, what's an important part is the new capabilities for wireline wireless convergence, and what I was already mentioning, this support for artificial intelligence machine learning, which will be developed in release 18. Those who are not day-to-day syncing in what's happening in 3GPP, currently we are working on release 17, and release 18 is scheduled to start somewhere in 2 years. Also worth of mentioning is the integration of or introduction of small indoor base stations that will integrate the residential LAN environment to 5G LAN. This is also expected to happen in release 18. So 5G is not yet done. There is still a lot of opportunities and work to be done in that area. But we have been starting now to look at 6G architectural, and how we did this exercise. It was that we looked at each of these driving elements and their evolution, and projected this evolution a bit longer term. So we started to look at these building blocks, how the platform is evolving, how the functionality of the network is evolving, how we implement specialization and virtualization, and what is the implication then to orchestration. Regarding the platform, which is very key component now because of the network functions and microservices, it's clear that we are moving into situation where there are multiple different type of heterogeneous clouds. That development we title het-clouds or heterogeneous clouds. It's a shortcut of heterogeneous clouds. Regarding the functionality, key development in that area is this run core convergence, where the some or most of the core network functions will merge with the run functions. We believe that there will be cell-free radio. Notion of cells is probably going to disappear in 6G. Information collection to enable this artificial intelligence will improve, and it will appear in each layer. It's not only a management layer functionality anymore in 6G era. Regarding the means of specialization, we are anticipating that there will be what we call personal subnetworks. And I will have one slide on that, but just to give the context of personal subnetworks. A subnetwork is, you can think it as a smartphone that has been disaggregated into parts, so that it's a set of devices that collectively form together an entity that we call subnetwork, that is part of the 6G network but has some autonomic capabilities. So it can function without this core network functionality, but still it can leverage the services what the core network is providing. It is not a private network though, so it's not that much of disconnected from the operator network. And then what is then happening on the orchestrator side or the network management side, that there will be this cognitive closed loop automation. So let's have a look at then the heterogeneous cloud environment. So here, this big cloud here is representing the current operator cloud with the microservices. At the bottom, we have a infrastructure as a service with hardware capabilities that we are exposing all the way to the microservices. And between there is a layer that we call as a backend as a service. And this is containing most of the telecom type of additions to the infrastructure service. For instance, it would contain replicated databases, load balancing, reliability, these type of things. And then we are also foreseeing that these operator networks, they start to support also function as a service type of solutions, so serverless approaches. And that's on top of this cloud stack, what we see. Okay, so this is the internals of a cloud, but then the operator is going to leverage public cloud services, or the public cloud is leveraging the operator services in the cloud form, so it can offload some functionalities to public cloud and vice versa, but not only limited to that cloud bursting, which is well-known thing already, some 5-10 years known thing. We have the edge clouds where we do the same thing, and then finally, and maybe more importantly, as a new concept is that we are most likely going to integrate the enterprise and private networks into the same cloud environment, so leveraging this notion of on-prem clouds, which means that some of these microservice components will be offloaded to this enterprise private network and vice versa again. What this means is that we need to have a capability to discover these clouds and the services what the clouds are offering in order to make a optimal and dynamic function placement. So this capability discovery here will play a very central role in order to use in optimal way these various service execution platforms that is going to appear as a complement of the core network cloud. So the operator cloud is kind of disaggregated among different collaborating clouds. And this collaboration is facilitated through this discovery functionality. The next big development is the disappearance of the boundary between run and core. We foresee that because of this cloud evolution that was mentioned previously, this is going to impact the boundary between run and core. So we don't need such kind of boundary there, because both run functionality and core network functionalities, they are executed in the same cloud. So we don't need that type of interfaces between these two domains. Instead, what we are going to happen to see is that these lower layer functions, that they will be, of course, that they need to be there where the signal is coming in, so in radio heads, in the cell side, but everything else is going to be microservice based and executed in this heterogeneous cloud environment. So there will be the At the control plane, we will see all the common things, what's currently there in the radio access network, radio resource control, mobility management, resource management, and also this radio intelligent control type of approach, which is a kind of SDN controller converted to deal with base stations and radio functions. A good example of this radio intelligent controller is coming from ORAN, this Open RAN initiative. Also, interesting developments is foreseen in the user plane activity. So all the higher layer RAN user plane functionalities will be co-located with the core network user plane functions, and there will be those functionalities that you currently find in the core network. There will be header compression, encryption, QoS policy enforcement, deep packet inspection, flow classification. This flow classification is going to play very important role because of the various types of traffic that is going to come into the network. So for instance, already now, in order to support time-sensitive networking, you have to separate that from the best effort type of traffic and so forth. This is going to traffic types are going to multiply in importance and in their requirements. And therefore, this flow classification or this deep packet inspection is playing critical role there. A second development is related to how the radio access is going to be organized. We see that these radios will form a mesh type of connectivity. So packets are routed through the stateless lower layer functions, creating a mesh network. And then we have here the anchor point in the cloud. And only here we then combine these flows. So these user equipment, they don't see cells, but they see that there is a radio connectivity offered, and the underlying routing mechanism is then bringing the flows into this user plane anchor, which is combining these flows. So this is multi-access, inherently multi-access, multi-flow environment. And then moving on to this quite new concept that we have dubbed as a subnetwork concept. As I mentioned, you can think it as a disaggregated smartphone, but here is maybe a bit deeper explanation what it is. It is meant for optimizing the functionality for the local environment as much as possible, extreme low optimization for the local environment. A subnetwork could be robot body network, so all your body network functionalities could belong into one subnetwork, and then it has one or two access points to communicate them to your healthcare provider. So it's connecting sensors and actuators. The subnetwork could be a device internal network inside a robot where reliability and latencies play extremely central role, but still these robots can interact with each other. And then it could extend even to drone type of networks. So different type of local networks, hyperlocal in-body networks with extreme reliability and latency capabilities, very special mesh type of networks for for unmanned aerial vehicles. They represent one aspect of or use case for these subnetworks. And then there will be some very special networks which are tailored for that certain purpose. For instance, monitoring environmental monitoring type of networks that require sensor devices with very long battery lifetime with using this new radio light type of approach, or even a better approach once we are in 6G era. So this is going to impact the topology of the network pretty much. It is going to, the endpoint is not anymore a device, but it is another network. And the core network can provide policies into this specialized network, and the subnetwork can leverage the services of the core network, for instance, for mobility reasons or reliability reasons. Also worth of mentioning that these devices, because they are still probably using spectrum from the operator, they are leasing the spectrum for their own usage, and then they need to coordinate. For instance, the density of these robotic arms or robots could be quite wide, so they need to control their spectrum usage. And in order to do that, they need services from the core network. Then if we move forward to information architecture and evolution of the network automation, all these presented 6G concepts, they require reconfigurability. For instance, when you offload network function or microservice from cloud to another cloud, that is representing a dynamic action, and for that to be most efficient, we are anticipating autonomous artificial intelligence, machine learning based decision making type of functionality at each layer, protocol layer and functionality. Here at the bottom, I'm depicting how we see the evolution of network management or network automation. I would say in LTE and early 5G, the keyword was self-organized networking, which was a rule-based management functionality. This is now gradually evolving during the course of 5G evolution into cognitive network management, and this cognitiveness is referring exactly to this i.e. machine learning based decision making capabilities, but here it is IEML functionality is contained within the network management. So the management functions become learning functions. And of course, in order to implement that, you need to collect the information. The network is data driven in order to make these sensible decisions. And this is going to then evolve towards cognitive network. And with this, we mean that this learning functionality is extended to the network functions themselves. So the network functions, these microservices, you might pick your favorite 5G network functions, let's say access management function, for instance. It will contain learning functions. So it can itself adjust to the environment and cooperate with the rest of the network functions. Of course, in each of these, there needs to be a human involvement, but here in this cognitive network, due to this learning process, the human operator involvement is only in very critical things when the system is not converging. Okay, so I'm reaching then to the summary of the presentation. As noted, the 5G evolution continues, at least next 2 or 3 releases. So release 19 will definitely be 5G release, maybe release 20. Then we are already hitting the boundary of 5G and 6G. 5G evolution is driven by the services exposed to the verticals and all those supporting functions that are needed for that. And the evolution is mostly software-based because of the fundamental architectural changes have for 5G has been introduced. The radio is not likely to change, and the execution environment is not likely to change that dramatically in 5G. And it is at that point where 6G is coming into the picture. So 6G is introducing new system architecture, both in hardware sense and software sense. The software architecture is likely to change, and what we have identified as a key developments is the support of these heterogeneous clouds, the so-called het-cloud, RAN and core convergence, disappearance of the boundary between RAN and core. We are not anymore using these SCTP-based communication channels and all that NAS signaling as such. We will see new type of means of customized and specialized the networks. The subnetwork concept was introduced for that purposes, to extremely adapt your networking capabilities to the local environment, but still using the operator coordination, for instance, for spectrum management. And then the management is becoming cognitive. The network functions are becoming cognitive, so they can adjust themselves. So that was the storyline, and there's more details in this mentioned article that I have used as a basis for my presentation.